Good afternoon. Welcome back to machine learning, the NSR programmer. Today we're going to introduce ensemble methods in machine learning. We'll understand the motivation for ensemble learning, reducing bias later, and variance using multiple models. So we'll learn key ensemble methods, that's bugging and boosting, which is subdivided into gradient boosting and AdaBoost, and then we'll see how combining models improves robustness and accuracy. So some few theories and concepts to discuss. We have what we call motivation or bias-variance tradeoff, and in there we have two words, bias and variance. Bias is an error due to model complexity causing sensitivity to training data noise. Bias is an error due to overly simplistic assumptions in the model, and variance is an error due to model complexity causing sensitivity to training data noise. Ensembles help reduce variance by averaging multiple high variance models, which is bugging, and then boosting reduces bias by iteratively focusing on difficult samples. So that is motivation, all under motivation. And then ensemble learning, this combines predictions from multiple models, aiming for better performance than any single model. And there are two key ensemble methods, and we have what we call bugging, which is bootstrap aggregating, and then we have boosting. The characteristics of bugging is one of them is that it creates multiple data sets by sampling with replacement from the training data, which are bootstrap samples. Then it trains a model independently on each data set, then aggregates predictions by majority voting or averaging. For example, random forests build many decision trees on bootstrap samples and average results. It reduces variance and then combats overfitting. And then the other method of ensemble is boosting, where it trains models sequentially, each correcting errors of the previous, assigns weights to misclassified samples to focus learning. Final prediction is a weighted sum of all models. Examples are AdaBoost, gradient boosting machines, and XGBoost. It reduces bias and can improve accuracy significantly. So we're going to dive into a Python example to demonstrate how to implement and compare the two popular ensemble learning methods, which is bugging and AdaBoost. We'll have a random forest. So bugging and then boosting, and we'll be using the iris dataset. Yeah, so let's begin by importing the libraries. this is it. So we start by, of course, importing the necessary libraries, and then we load the iris dataset and split it into a train and test, 70% being for training and 30% being for testing here. And then we initialize and train a random forest with 100 decision trees, which is bugging. Yeah. Of course, then we'll print those results. And then, yeah, so like I was saying, we initialize a train and train a random forest with 100 decision trees, which is bugging. Then we predict and evaluate using the classification report and accuracy. And then after that, this second block of code from line 21 to 27, we've initialized and trained an AdaBoost classifier with 100 iterations, which is boosting. And then of course we predict and evaluate the AdaBoost similarly to compare ensemble methods. So in summary, we've used bugging by training 100 decision trees on different bootstrap samples of the training data. Then the code combines the predictions by majority voting to reduce variance and improve robustness. And then it shows how bugging stabilizes predictions and reduces overfitting. And then the second bit, the AdaBoost classifier, trains an ensemble of weak learners sequentially, where each new learner focuses on samples the previous learners misclassified. It then aggregates the weighted predictions, reduce bias and improve accuracy, especially on how to classify samples. So both models are trained on the same training split and evaluated on the test split with detailed classification reports showing precision, recall, difference score, and overall accuracy. Our expected output will highlight how ensemble methods typically outperform single models by improving accuracy and providing more reliable classification. So in essence, this code example is going to illustrate the practical application of ensemble learning, showcasing how combining multiple models leads to stronger, more accurate classifiers in machine learning tasks. So when I run it, then we'll look at the output. It's only showing the AdaBoost accuracy score. show it's this one, but it's supposed to display it like this. Okay. So the first bit, so you can see both ensemble methods show improved accuracy compared to a single decision tree. So both classification reports provide precision, recall, and F1 score per class, showing robust multi-class performance. So the random forest will reduce variance, and then the AdaBoost focuses on hard examples, reducing bias. Yeah. That's it for today regarding ensemble methods in machine learning, particularly bugging and boosting. Thank you for tuning in. Like the video, subscribe to the channel, and share. Leave a comment as well. Have a blessed evening.